Great. Hi, everyone. First of all, thank you so much for coming to my talk, which is somewhat philosophically titled The Sum of Nothing. This is actually not a talk about how to fill in missing values and use statistical methods to deal with missing data per se, like interpolation or whatever. So if that's what you were looking for, I won't be offended if you go to a different talk or it's not what you discovered and you want to leave. Totally fine. Actually, this is a talk about my journey with the Python library pandas. So a little bit about me. My name's Christine Zhang, and I don't consider myself a Python developer or a Python expert, although I do love the animal pandas. I'm actually a data journalist at the Baltimore Sun, where it's my job to analyze and visualize numbers and statistics for news stories. So why am I here at a New York City-based Python developers conference, you might reasonably ask? Well, I actually, before I joined the Baltimore Sun, I used to work here in New York at the tech company 2 Sigma, where my job title was data scientist. So data scientist, I'm kind of mixed about that term. It's somewhat nebulous, and I really like this quote by Noah Loring. He said, "Sometimes I'm called a data scientist, mostly I just do arithmetic, and I'm okay with that." I like it because I think it's a true statement, but I also think that doing arithmetic can be more complicated than you'd think, especially when it involves libraries that might not behave like you'd expect. I'm talking specifically about pandas, of course. So how many of you have heard of pandas? Okay, so that's most of you. Just briefly, pandas is one of the main tools used to do arithmetic on data frames, or also known as analyzing data in Python. It stands for panel data analysis, but I also like to think it's a play on words with the snake and the panda. In this talk, I'll go through the history and drama behind how pandas works with missing values, and again, my own journey from love to hate to acceptance of its default behavior. So first, let's get some data. Consider these 3 questions. How many cups of coffee have you had today? How many books have you read this month? And how many hours of TV have you watched this week? So since I couldn't survey you guys beforehand, I had to create my own imaginative data frame. Now, imagine a world where there's just you, me, and Bob in New York City. So in this world, you've had 1 cup of coffee today. Very good. I've had 2. And Bob, who, let's just say, had a late night, has had 3. You've read 1 book this month. I've read 2. And Bob, well, he got all cranky and he refused to answer the question. He left the room, maybe to get his 4th cup of coffee. I don't know. He's gone. He's not answering any more questions. So whatever. As for the hours of TV, maybe neither you nor I could remember. I mean, that's kind of a specific question. So we also didn't answer that question either. Now, I've put all this info into a pandas data frame that I'll call D. Now, NaN here stands for not a number, AKA missing. So if I want to know the total cups of coffee the 3 of us said that we drank, I'd want to sum this column using the pandas sum function. What should the sum be? Don't worry, this is not the complicated part. Yes, it's 6, right. And this is right, great. A slightly more complicated question maybe, if I want to know the total number of books that we said that we read, what should the sum of the books column be? How many of you think pandas should return 3? Okay, and how many of you think it should return a NaN because Bob refused to answer? Okay, interesting. So actually, pandas gives me back 3, which is fine. Some of you thought that it would because 3 books are maybe the known number of books that were read. But what about this TV column? What do people think that the sum of the TV column should be? Okay. The sum of nothing, in a sense. So I heard 0. Okay, I heard NaN. So you probably know the answer if you've read my talk description. But regardless of how Panda does behave, I'm kind of thinking about how pandas should behave. So it actually does give back 0. And when I noticed this, like I use pandas sometimes, but I was using like a different version and whatever. So I noticed this and I was horrified. And I'll tell you why. It's not just about you, me, and Bob. It's actually like, what if I wanted to compare the three of us in New York to, say, Harry, Hermione, and Ron at Hogwarts? Any Harry Potter fans? All of whom did answer the TV question. Hermione said 0 because she was too busy studying. Is it fair to say that in total, like in New York City, everyone watched 0 hours of TV, while at Hogwarts people watched 22, which is what you'd get, by the way, if you just ran pandas sum on each of these columns. Well, no, because there's actually a big difference, right, between a missing value and a 0 value. It was baffling to me why pandas would do this, especially since if you take the mean, you get back a NaN. If you take the min, you get back a NaN. Take the max, you get back a NaN. And if you take the product, which is if you multiply all the NaNs in that column with each other, you get back a, you get back a 1. So what? So this is really, like, this behavior for the sum and product of nothing really tripped me up. As the ancient Greek philosopher Parmenides once wrote, and I'm paraphrasing here, because I don't know ancient Greek, something cannot come from nothing. Now, it didn't used to be this way. When I'm talking about pandas, I'm talking about the newest version, 0.23.4. So in an older version, which I referred to earlier, 0.21.1, the sum of a column of NaNs would actually, in fact, be NaN. So what happens? Well, what number comes between 21 and 23? 22. So 22, pandas 0.22 was a major release, and it seems like they made just one API breaking change. The sum of all in all NaN series was now 0, and the product was now 1. They also added this thing called a min count parameter, which, all right, let me see if I can get this right, which represents the minimum number of valid terms that have to exist in the column in order for the function to evaluate. That is a mouthful. So like if I put min count equals 1 in these functions, the sum and product of the TV column would both be NaN, which was the behavior that I had expected in the first place. Okay, like I could do that, but why? I mean, it seems like a pretty convoluted thing to do to get back to that original behavior. And it's interesting that in another programming language, R, which I also use to analyze data, the default behavior is to return an NA value for the sum of the TV column. So by the way, R displays missing values as NAs, not NaNs, but it's pretty much the same. And R is actually pretty careful when it comes to NAs. So like some of you said, like, oh, can you not see the NaN? Because I can't see, or whatever. But like with the books column, it won't add 1 and 2 together because Bob refused to answer. So it's pretty much like the opposite of pandas in that it forces you to specify that you want to remove NAs via the NA remove equals true parameter. So like, what's going on here? Like, why pandas? Why would you do this to me? This is part of the reason why I knew I had to go work in journalism, because my first instinct was to look up the people responsible for the pandas API change and ask them why they did it. You have to hold them accountable for their actions, right? Some of you might know of Wes McKinney. Who knows of Wes? So Wes was the founder of Pandas back in 2008, I believe, and he's the quote-unquote benevolent dictator for life. But I figured out who I really wanted to talk to was Jeff Reback, one of the core developers who currently manages the project. And as evidenced by his GitHub commits here, I don't know if you can see, he's been the one to commit in recent years to the Pandas source code. It also helped, by the way, that Jeff happened to work at the same company as me at the time in New York, making it harder for him to avoid me. So I found him one day in the office. I went down to his floor, and he very nicely sat down with me for an hour to talk about it. And the funny thing is, he himself agrees that the sum of a column of NaNs should be NaN. And so should the product, for that matter, in his opinion. But the issue, it turns out, is more complicated than that. In fact, it wasn't as if they suddenly and spontaneously decided to change the pandas behavior in version 0.22.0, which is what I thought that they did. Rather, the reason that they had to think about this in the first place actually stems even further back to pandas version 0.20.3. So bear with me. I'm going to do like a demo of what I'm talking about. Hopefully this works. OK, so you see here, this is D. And just to like show you that I'm actually, wait, can I not do it? I'm trying to show the thing. OK. Maybe I have to put it away and then do it. OK. So, no. OK, I tried to do the live coding thing, but I think this is a bad idea. So I'm going to go back. You're just going to have to take my word for it, or you could download 0.20.3, but it's a little complicated. So taking my word for it means that you could have two terminal windows open with pandas version 0.20.3 running like simultaneously, okay? And in one window, when you try to sum the TV column of NAs and NaNs, you get a NaN. In another column, you get a 0. Same version of pandas, same version of Python, different behavior for the same exact function. Why? Does anybody have a guess?
Does it have to do with the typing of NaNs, whether it's a mobile or not?
Nope.
No? Okay. I'm going to say types.
Types, nope. It actually has to do with this thing called bottleneck, which is an optional dependency that pandas can call upon to perform operations. So pandas usually uses NumPy, but sometimes also uses bottleneck. I don't know. So bottleneck like performs the operations, basically, if it's installed. But if it's not installed, it doesn't. So if it's not installed, it'll return NaN. If it is installed, it'll return 0. But how are you supposed to know whether or not bottleneck is installed? It's not as if pandas requires it to be installed, so you wouldn't know. This is why you could have the same version of pandas, the same version of Python, different behaviors. Anyway, I think we can all agree that this is very bad. Wish I could have showed you, because that would have been cool, but it's OK. But at least like you agree that pandas should be consistent with its behavior, right? And the core developers agreed, too. So when this issue came to their attention, and that's a long story in and of itself that I won't get into here, they realized that they had to choose a default behavior. What's it going to be, 0 or NaN? And they thought about it. And if you remember, I said that Jeff Reback, one of the core devs, agreed with me that the sum should be NaN. And so that's what he changed it to in pandas 0.21.1. But in his words, I made the sum of an empty list to be NaN, and the world screamed. He wasn't kidding. So if you're bored one day, you should go to issue number 9422, which, by the way, he's like memorized that number by heart because it's like in his mind forever, on the pandas-dev GitHub, and just look at the hundreds of comments, some of varying levels of civility. They even put out a call for feedback on the pandas-dev mailing list, which I didn't know was a thing, but it's a thing. Suffice it to say, a lot of people were very upset that the sum of all NaNs was now changed to be NaN. When he said this, I was like, I don't get it. Nothing can't turn into something. So it seems pretty intuitive to me that a sum of a column of missing values would also be a missing value. What's the problem here? This is where math comes in. And I'm actually going to go back to my comparison between R and pandas to show you what I mean. Here's the thing. Like the word nothing can actually mean very different things when working with data. NaN or NA is meant to indicate that there's missing data, as in there perhaps should be values in these cells for TV that Bob didn't answer, or none of us answered, but it's missing for some reason. And I know that I said NaN or NA was nothing before, but philosophically it's actually something. Like it's a placeholder for missing data values. So it's only when you remove the NaNs or the NAs, which happens in pandas by default, and in R via NA/RM equals true, that you truly get a column full of nothing, by which I mean an empty column. And what is the sum of this empty column? The two programming languages agree it's 0. So this got like a little bit trippy. So here, like I want to just show you, like here's the R code. Once we remove the NAs from the TV column and we sum it, we get an empty sum. So essentially, like these two code chunks are functionally exactly the same. And it's the same with pandas. This is this sum of this null thing. And in math, it turns out there's this thing called an empty sum, which by definition is equal to 0. It's one of the basic math conventions. Clearly, I'm not a math person because I had no idea that this was the case. And it's hard for me to understand this abstract concept, but it helps for me to think of it like with a different example. So say that like I went to the bookstore and bought all 7 Harry Potter books because I really love Harry Potter. And 2 of you came along with me, but like you 2 didn't get any Harry Potter books because you don't like Harry Potter. So I had 7 books, and you 2 each have 0. And so 3 of us together, we have 7. 7 plus 0 plus 0. Okay, that's easy. But say that you 2 didn't even come along with me to the bookstore at all. Like you overslept, you totally forgot to meet me for our bookstore outing. In this case, you can think of me as me. I have 7 books, and you individually have NA or NaN books. You don't have 0 books because it's not like you chose not to buy any books. You didn't even show up for the occasion. But together, we still have 7 books, right? So in this example, the 2 of you could be seen as the empty set. Empty is an apt description of life without Harry Potter. And in order for the fact that between the 3 of us, we still have 7 books to hold true, the 2 of you together, the sum of your empty set here has to be 0, right? So in other words, in the right context, it does make sense for the sum of nothing to equal 0. And I actually get it now, like why maybe you'd want to be mathematically correct. And so I can understand why the math people were all up in arms about it with pandas 0.21.1. All right, but still, what I could really not wrap my head around was this idea of the empty product. Like, the product of an empty column is 1 in both R, again, once you remove the NAs, you're left with empty, and in pandas too. And I didn't find the documentation to be particularly useful in explaining why this was the case. And the Wikipedia entry was also a bit inscrutable. Instead, and warning, this is really hacky math, so if anyone has a better way of explaining it, please do let me know. The way I think about it is by having some fun with the Euler's number, or E. So E can be expressed as e to the power of 1. It's like taking the product of 1e. This can also be written as the power of e to the power of 1 plus 0. Yet another way of displaying this equation, thanks to the product rule for exponents, is e to the power of 1 times e to the power of 0. We know that this expression has to equal e. So what does e to the power of 0, in other words, an empty product or a product of 0 e's, have to equal in order for this to happen? 1. Yes. So the empty product is 1. Proof. Not the QED kind of proof, but my way of proving it. And as a friend of mine put it, the product of an empty set has to equal 1 because otherwise all exponents don't work ever, and all math breaks. In summary, I think the mathematical considerations here are valid. Not that that's always the only consideration, because pandas is not a math library. Here are the words from the BDFL himself. The broader challenge for a library like Pandas, I think, is that there are so many different kinds of users. And even if they did look at feedback from GitHub and the pandas-dev mailing list and all that, it's not entirely clear that a representative sample of the user base posts in those channels. So Jeff Reback told me that I was the only one who complained about them changing the sum of an empty list to be 0 and the product to be 1, even though he agreed with me. And I complained about it and noticed it after the fact because I didn't realize that these discussions and debates had even occurred in the first place. But like I said at the start of this talk, I'm no expert. So here's some takeaways in the form of a few closing quotes from others. During his talk on Python oddities yesterday, which I encourage you all to watch again, Trey Hunter said that if you found something that looks like a bug, you might just be misunderstanding the trade-offs that the core developers had to make. I think that very much applies here. These include the trade-offs between being right from a mathematical standpoint, being right from a data standpoint, and being right from an intuitive standpoint, whatever right means. True, this quote from our friend Parmenides says something cannot come from nothing. But maybe, it's time for an updated philosophy. I'll leave you with this one from jazz composer and poet Sun Ra, referenced in Yo La Tengo's 2000 album. At first there was nothing, and then nothing turned itself inside out and became something. You may not have followed my admittedly hacky math today, but remember this: arithmetic is not simple. Programming libraries are created by humans, and if you are working with missing data and you're not careful, nothing can in fact turn itself into something. Thank you. Yeah, yeah, that's real. Well, yeah. I did not take that picture. It was somebody else on Twitter, yeah. Do I have time for questions?
You have a few minutes for questions.
Okay. Yes.
One question or observation is that my understanding is that Pandas is built on top of NumPy. NumPy is a math library, and so it seemed like it would default to whatever the mathematically correct definition of it was. It brings back floats rather than numbers. Now, I agree it doesn't make any sense to sum missing values and get something back, but that's probably some perverse thing. It's your responsibility to know enough math and what NumPy does and doesn't.
Yes.
To take care of this, but it's not obvious for sure.
Right. So yeah, the comment was that it's your responsibility to know what's going on, and Pandas is built on top of NumPy, and so yeah, I do believe the NaN sum function thing in NumPy behaves this way. So that's why they also made it behave this way.
It also has to do with sets, right? So does R use sets? I used R, but I don't remember if it does or not.
Sets?
Sets. You can define sets, and so we're talking about the set.
Yes. Yes.
It could be related to that as well, which is more of a mathological operation than it is a data.
Right. Yeah, I think one thing is that R was built by statisticians for statisticians, kind of, so they say, and so it was very mathy even from the very beginning. So, yes.
It was felt so adamantly that Pandas is not strictly an arithmetic library. Why? And furthermore, it looked like it's showing us that NumPy handles it in the intuitively correct and mathematically incorrect way, which is bottleneck, fucks things up. Albeit in the mathematically correct way. Why did they make the decision to then make it the default and not just reverse it in its features?
I'm not sure.
I mean, we're supporting both cases now, which is going to be the default, and I'm just curious that if you felt so strong about it, how did it become the default?
Well, one answer is that.
And also, it might not actually be a dictator.
Yeah. So Yeah, I have to admit I'm not super well versed in the intricacies of bottleneck and NumPy and how they interact with each other. But the question is, if Wes McKinney felt so strongly about it, why did he just, exercise his BDFL right and do it? I don't know. I haven't asked him. I don't, talk to him regularly. But what I would say is maybe this is the triumph of democracy over dictatorship. Yeah. Or it's like mob rule. Depends on how you look at it, right? So, yeah. Yes.
Do you know what happened before 20? Like, was it always before 20, like either 0 or like and depending on what was installed, and it just never was consistent until 21?
That's a good question. So the question was, do I know what happened before 0.20.3? And the long story of it is that I think bottleneck was the thing that changed the way that it would render. So I said that if bottleneck was installed, it would return a 0. Is that right?
Yeah.
Yeah.
Bottleneck is NumPy. I mean, just
Oh,
put it up
okay.
here. It says bottleneck is a collection of fast NumPy array function written in C.
Right. So that wasn't always the case, and they had that behavior had changed, and they noticed that it had changed in 0.20.3, and so then they had this discussion of, well, now we have to choose a default behavior. Which one do we choose? And then they originally did pick the NaN one, but huh?
Which would correspond to the NumPy operations.
So they originally did pick the NaN one, right? And then everyone said, no, this is bad, and then they changed it back. Yeah. Oh, do we have to? Okay. I will be in the hallway. Yeah. Thanks.